Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 13 of electronics. Okay. Um, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also guys, share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started guys. Meanwhile, let me just check whether I'm audible or not, then I'll proceed further. Guys. Meanwhile, let me just check whether I'm audible. I'm audible, and so I'm going to proceed further. Okay. Okay. So electronics, guys. Okay. So today we are going to study rectifiers. Okay. Rectifiers. Rectifiers. So what is rectifier, guys? Rectifiers. Rectifiers. Okay. So rectifier is it converts AC into DC. Okay. So rectifier means converts, these are points I'm writing. Okay, converts converts AC into DC. These are just point. Okay, so rectifier there means it converts, or rectifier converts AC into DC. Okay, so converts AC into DC. Okay, so work of rectifier is converting AC current into DC current. Okay, so now first one is half wave rectifier. Half wave rectifier. Half wave rectifier. Half wave rectifier. Okay, so half wave rectifier, what will do? This we have a wave. Okay, sinusoidal wave. So half wave rectifier is like this. Okay, it is made of diode and resistance. So this is diode, guys. Okay, and then this is resistance in parallel, RL. Okay, and there is, this one is V naught. Okay, so this is the uh, circuit for half wave rectifier, diode and resistance. Okay, so what it is going to do, this will convert this AC current, this one, into direct current. So direct current is going to be like this. Graphically we can represent like this. Okay, so this is the current, and this is 0 to pi, and 2 pi, this is 3 pi, this is 4 pi, and this is 5 pi. This is 5 pi. Okay, so this is the graph versus V naught, V output. Okay, and this is, guys, VM, input voltage. Okay, so this is the so we have this AC current and it has converted this into DC. Okay, so this is the work of rectifier. Now I'm going to explain average value of output signal, or average value of voltage. Okay, output voltage. So average 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 value of output signal or output voltage. Okay, average value of output voltage or output signal. Okay, so first there is a formula, guys, for getting average value of voltage. So V average, this you need to note down. Okay, V average, this is V average. V average equal to 1 upon T integration 0 to T integration 0 to T V naught dt. Okay, so this is the formula, guys, for getting V average. Okay, V average equal to 1 upon T. T is the time period, guys. So in this case, time period is 2 pi, right? This is 2 pi and this is 4 pi, right? 2 pi. So 1 upon T 0 to T, 1 upon T integration 0 to T V naught dt. Okay, so this is the average value of voltage. Okay, average value of voltage. Average value of voltage. Okay, so now this we have V naught. V naught is, we have this one, Vm, Vm the input voltage. Okay, Vm sine omega t. Okay, so we have this voltage, that is Vm sine omega t. Okay, so where this value is this one. I'm talking about half wave rectifier. Okay, this one. So between 0 to pi. Okay, so V naught is Vm sine omega t when t is between 0 to pi. Okay, and this V naught is 0 when it is, that t is between pi to 2 pi. Okay, so this one, pi to 2 pi, you can see the value is 0. 3 pi to 4 pi, it is 0, right? And 0 to pi, it's V naught, Vm sine omega t. Okay, so this is the voltage. Now, so we have got the output voltage. So we have this output voltage, guys. We have defined this is Vm sine omega t, and t is between 0 to t. Okay, if t is between pi to 2 pi, then this value is 0. Okay, this is the V naught. So now we'll find V average. V average. V average is going to be 1 upon t, means by this formula. So 1 upon t is 2 pi, right? And this, in case of this half wave rectifier. So this is going to be 1 upon 2 pi, 1 upon 2 pi integration Vm sine omega t, V naught value, sine omega t into d omega t, guys, d omega t, and this is 0 to pi. And this value is going to be pi to 2 pi, this value is going to be 0, right? So V average is going to be, V average value is going to be, V average value is going to be this one. So we'll solve it, right? So this is going to be, if we solve it, this is going to be Vm, we'll take outside Vm upon 2 pi, and this is going to be minus cos omega t and 0 to pi. Okay, so this value is going to be, V average value is going to be Vm upon pi. Okay, so this is V average. This is important formula, guys. Okay, V average is Vm upon pi. V average is Vm upon pi. Okay, and this is also called DC. VDC means voltage of direct current, that is DC. Okay, next is so we have got this V average, right? And now similarly, I average is going to be, I average is going to be Im upon pi. Im upon pi. Im upon pi, or that is, we can see IDC. So current, direct current. Okay, this one. This is also important one. This is also important. Okay, V average equal to Vm upon pi, VDC. Next is RMS value of, so this is the average value we have find. Now we are going to find RMS value. Okay, RMS means root mean square value. RMS value of output voltage. Okay, output voltage. RMS value of output voltage. RMS means root mean square. Okay, root mean square. This is root mean square. Okay, so RMS value of output voltage. Okay, so this is going to be VRMS. VRMS is going to be root V average square, right? So this is going to be root this one VM. So you need to know, guys, VRMS is root V average square. Okay, so VRMS is going to be VM upon 2 pi, VM upon 2 pi, VM square upon 2 pi, and this is going to be integration 0 to pi sine square omega t d omega t. Okay, this one, and plus plus pi to 2 pi, plus pi to 2 pi 0. Okay, this one, this is the VRMS. So because we know VRMS equal to root of V square, right? This one. Okay, so this value is going to be, to solve it, that VRMS is going to be that value is going to be root VM square by 2 pi, VM square by 2 pi, okay, into pi by 2. Okay, so means, so VRMS value is going to be VRMS root mean square velocity, that is VM upon pi. VM upon pi. Sorry, VM upon pi will get cancelled. VM upon 2. VM is the input voltage, guys. Okay. VM upon 2. VM upon 2. Okay. And IRMS is going to be IRMS is going to be IM upon 2. Okay, so this value is value is VAC, and this value is IAC, right? So this is the voltage for AC, and this is the current for AC. Okay, so VRMS is this one. This we need to note down. Okay, so IRMS equal to IM by 2, and this is VAC, that voltage of that AC, and voltage of current of AC. Okay, important thing. Okay, so now we have got these things. Now I'm going to find, that is form factor, guys. Okay, form factor. Form factor. Form factor. So form factor F is going to be VRMS upon V average. This is the form factor, guys. Okay, V average. So VRMS equal to that, the form factor equal to VRMS upon V average. Okay, so RMS voltage upon average voltage. that is called form factor, and this value is going to be Vrms value, we know, right? Vm upon root 2. Okay, Vm by 2. Vm by 2. My apologies. Vm by 2. This one. We have got this, right? Vm by 2 and this Im by 2. Right? So this is Vm by 2 and V average value we know. So that is Vm upon pi, right? So Vm is going to be cancelled and this value is pi by 2. Okay. So now we'll find ripple factor, ripple factor, ripple factor, ripple factor, ripple factor R, that is going to be root f square minus 1, that is f is form factor, right? So this value is going to be pi square by 4 minus 1, this is the f, right? And this value is going to be almost equal to 1.21. So ripple factor for half wave rectifier is 1.21. Okay, 1.21. 1.21. Okay. And ripple factor is called unwanted signal. Okay, this is unwanted signal. Unwanted signal. Unwanted signals, that is ripple factor. Okay. Next, peak inverse voltage, guys. Peak inverse voltage. Peak inverse. Peak inverse voltage. Peak inverse voltage. So that is, what is peak inverse voltage, guys? I'm going to write it. So maximum reverse voltage. Okay, peak inverse voltage means maximum reverse voltage, maximum reverse voltage. Okay, so I'm talking about reverse voltage. Okay, maximum reverse voltage a diode can withstand. Okay, diode can bear. Okay, so a diode can withstand, diode can withstand. Okay, so maximum reverse voltage. So peak inverse voltage means the maximum reverse voltage a diode can withstand. Okay, so that is peak inverse voltage. Maximum reverse voltage a diode can withstand or bear. Okay, and peak inverse voltage we can write in short, that is PIV, peak inverse voltage. Okay, and that is equal to Vm, input voltage Vm. Okay, in case of half wave rectifier. Okay, now output DC power. So now at power. Okay, output DC power. DC power. Okay, power means DC, direct current power, output power. And formula we know, P equal to Vi, right? So this is PDC, PDC equal to VI, VDC into IDC, because power, that output DC power we are talking about. So output DC power means that PDC is going to be VDC value, we know that this for direct current, this is average voltage, right? That we know, that Vm upon pi into IDC is Im upon pi, right? So this value is going to be Vm Im upon pi square. Vm Im upon pi square. Okay, Vm Im upon pi square. Vm Im upon pi square. Okay, Now output power, output AC power, alternative current power. Okay, this was the output DC power. Okay, VMIM upon pi square. So the output AC power, that is going to be that PAC equal to VAC into IAC, right? And VAC value we know that, right? That is VM upon 2, VM upon 2 into IM upon 2, IM upon 2. So this value is going to be uh, VM IM upon 4, VM IM upon 4. This is PAC, okay? That alternative current power, right? And the efficiency for this half wave rectifier is, efficiency is P PDC upon PAC, right? PDC upon PAC. So PDC upon PAC, we know the both value, right? Here PDC value is this, so we can write here, this is going to be PDC value, that is that if you put the value, so this is going to be 4 pi square, and that value is 40.53%. So this is the efficiency, okay, 40% 53 for half wave rectifier. Okay, now full wave rectifier. Now full wave rectifier. Full wave full wave rectifier. Full wave rectifier. Okay. So full wave. So in full wave rectifier, first is center trapped full wave rectifier. Okay. So center trapped full wave rectifier. Okay. In short, I'm writing FWR, full wave rectifier. So center trapped full wave rectifier. Okay. So this will convert AC into DC, right? So this is the alternative current. Okay. So here I'll make for this diagram for this full wave rectifier, that center trapped full wave rectifier. Okay. So this is like this. This is diode. Okay. These are diode, and this is this. Okay. This plus minus and then minus plus. We can take for first cycle, second cycle. Okay. So these are transformer. So this is the full wave rectifier diagram. Okay. Full wave. These are two diode, and this is the load resistance. Okay. And so this is the alternating current, and then this current is going to be converted into direct current. Okay, so and the output diagram for this voltage is going to be like this. Okay, so this is 1, this is 5, 2 5, 3 5, 4 5. Okay, so this is the output voltage. Okay, so now this is the one, this is the diagram. Okay, so for what we are going to do, for we are taking for plus half cycle. Okay, for plus half cycle, for plus half cycle, for plus half cycle, you can see that if we talk about plus half cycle, diode D1 is diode D1 and D2 are forward biased. D1 is forward biased and D2 is reverse bias. Here you can see, if we take plus here, so this is P part, this is N part, right? P N. So this is plus, right? Plus means, yeah, plus minus, right? So plus means this is forward bias and this is reverse bias. This we can say diode 1 and this is diode 2. Okay, forward bias, and this will be reverse bias because this is negative here, right? Reverse bias. So in that case, and for negative half cycle, if we take negative half cycle, okay, negative half cycle, so this will be positive, this will be negative. Okay, negative plus P, this is reverse bias and this is forward bias. So in that case, D1 is reverse bias, D1 is reverse biased. I'm writing in short RB and FB for forward bias and RB for reverse bias. RB and D2 is forward bias. Okay, and this V naught equal to V in. Okay, and V naught equal to V in. So this is for positive cycle and negative cycle, and this is the center trapped full wave rectifier. Okay, so now we'll find V average, and that value is going to be 1 upon 2 pi, formula we know it, 1 upon t into 0 to 2 pi, 0 to 2 pi V naught d omega t, right? V naught sine omega t d omega t, right? Because now this will be for full, right? Full wave means for this 0 to 2 pi. Okay, so this value is going to be, because it's full for, right? At that time this was 0 to pi, now this is 0 to 2 pi, so this is going to be this value, V average value in this case for full wave rectifier, V average value is going to be 2 Vm upon pi, 2 Vm upon pi. Okay, and similarly I average value is going to be 2 Im upon pi. Okay, and Vrms for AC, that value is going to be Vm upon root 2. So here Vm upon root 2 will, okay, and in case of that half wave rectifier it was Vm upon 2. Okay, so and Irms is going to be root mean square current, that is Im input current upon root 2. This 2 Vm upon 2 Im upon 5, right? These are important formulas for full wave rectifier. Okay, next is that this one, form factor. F is going to be this one, right? Vrms upon V average, Vrms upon V average, Vrms upon V average, and that is going to be Vrms. We know for full wave rectifier, this is Vm upon root 2, and for this 2 Vm upon pi, right? So this value is going to be Vm will get cancelled, pi upon 2 root 2. This is the form factor, okay? Pi upon 2 root 2. Pi upon 2 root 2. Pi upon 2 root 2. And this ripple factor R is going to be root f square minus 1. So this is root pi upon 2 root 2 whole square minus 1. And if you solve it, this value is going to be 0.48. Okay. Okay, now we'll find this PDC, that PDC means power of direct current. Okay, so this is going to be 4 Vm Im upon pi square, and PAC, this value is going to be Vm Im by 2, Vm Im by 2, Vm Im by 2, Vm Im by 2. Okay, so from here we can find this efficiency. Eta value is that 8 upon pi square, right? Eta is I have already explained this eta. Eta is PDC upon PAC, right? So PDC upon, this is PDC upon PAC. I can write here. Okay, so this is eta is going to be this one. Okay, so if you solve it, so this value is eta's value is going to be 8 upon pi square, because this upon this, if you do, that eta equal to 8 upon pi square, right? So if you solve it, this value is going to be 81.06%. So very high efficiency compared to half wave rectifier, right? Just double. Okay, so this is the efficiency for this one, for full wave rectifier. Okay, first one. Now guys, peak inverse voltage. So P for peak inverse voltage, peak inverse voltage, peak inverse voltage, peak inverse voltage, that we can, in short, we can write it PIV. Okay, so for peak inverse voltage, we can take this loop. Okay, RL, this one loop, this one. Okay, okay, and then this is going to be like this. Okay, so this is RL and this is 1 and this is V0, RL V0. Okay, so here, and this one is PIV, peak inverse voltage. Okay, so in loop, if in this loop, this is loop 1, this is 2. Okay, KVL in loop 1, that is going to be Vm, this is minus Vm, and this is plus Vm. Minus Vm plus Vm. So in this loop, this is going to be V minus V naught equal to 0, implies value of V naught equal to Vm. Okay, and in loop 2, KVL in loop 2, KVL in loop 2, KVL in loop 2, you can see minus Vm plus PIV, PIV is V naught, right? PIV PIV minus V naught equal to 0. So from here you can get PIV, peak inverse voltage is 2 Vm. Peak inverse voltage is 2 Vm. Okay. So this is important one. Peak inverse voltage for full wave rectifier is 2 Vm. Okay. 2 Vm. Next for this, for center, this one for center trap. Okay. Next is this full wave rectifier. Now bridge rectifier, guys. This is also full wave rectifier and known as bridge rectifier. So second is bridge rectifier. Bridge rectifier. So this I'm going to make a diagram first. Okay. Coil. These are two coils. Okay. And then there is diode. These are diode, guys. Okay. This is D1. This is D2. This is D3, and this is D4. Okay. And then there is RL. This one. D1, D2, D3 and D4. Okay, so this is D1, this is RL, this is output V0. Okay, so these are D1, D2, D3 and D4 diode. Okay, and so this is the bridge rectifier, guys, or this is the half wave rectifier. Okay, so now for this for positive half cycle, for positive half cycle, for positive half cycle, this D2 positive half cycle, D2 and D3 are forward bias. Okay, this one D2 and D3 are forward bias, for plus or this one. Okay, forward biased, and D1 and D4 are reverse bias. D1 and D4 are reverse bias. Okay, for positive half cycle, you can see for positive half cycle, this is forward by the D1, this one D2 and D3 are forward bias, and this is D1 and D4 are reverse bias. Okay, so now and for this bridge rectifier, we can I'll make a diagram and I'll find peak inverse voltage. Okay, PIV. So this is going to be like this, plus PM. Minus PM. Okay, this is V0, and okay, so these are this one, and this is like this. This is S minus, this is R. Okay, we will take like this and this. Okay, so from here we can get peak inverse voltage PIV in by KVL. Okay, by KVL, PIV by KVL. This is going to be minus this VM, this one. Okay, VM minus V0, this one V0. Okay, plus PIV. These are PIV. Okay, PIV plus PIV, PIV plus PIV, that is going to be equal to 0. So from here we can get 2 PIV, PIV, 2 PIV, that is peak inverse. PIV is peak inverse voltage, guys. Okay, that is going to be 2 V0 and VM, right? Any mistake we are doing? This will be this one V0 and this, and V0 equal to this one. Okay. So PVI is going to be this 2 VM. Okay, so from here PIV value is going to be, the peak inverse value is going to be, PIV is going to be VM. Okay, yeah, VM. this one. Plus, okay, so to 2 PVI, not plus, VI and VI. This is minus, okay, and this will be also. So V naught value is minus Vm, right? This is 1. Okay. So we have used KVL and we got this value, right? PIV is Vm, okay. So this is the peak inverse voltage for bridge rectifier, guys, okay. Peak inverse voltage for bridge rectifier, and this is the bridge rectifier. So this is the guys half wave rectifier and full wave rectifier, okay. So guys, I'm going to stop here, and remaining part will do in next class. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. And also guys, please share my lecture details with your friends, so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, thank you so much. Bye now.